So we left off on example 6. McKenna, what does example 6 want me to find? And then B? This is a missing mass question. And so Sky, if they only give me one mass, I'm not going to go winner minus loser equals M all A, because I don't know M all. I don't know both masses. We're still going to do a free body diagram. What are the forces acting on mass 1? Get the obvious one. We would say M1G tension, M2G tension. And I also said, Chase, I have to tell you which way we're accelerating. Otherwise, you can't solve this. It says, McKenna, that M2 is accelerating which way? So I'll probably just put a little arrow here with an A there to remind myself that's the winning direction. Just so I don't get interrupted partway through and forget. Is that okay? Lillian, which mass do I know? I'm going to write an equation for mass 2. In other words, don't do this yourselves, but look up. I'm imagining that mass 1 is completely covered up and not even part of this question. Which way is mass 2 accelerating? Up or down? Alex, which way is... Yeah. So which is the winning force on mass 2? Which one? There's two of them. Thank you. Which is the losing force on mass 2? And that's going to be M2A. I'm not going to go to the other ones. I don't know it. McKenna, what did A want me to find? Okay, let's see, get the T by itself. Can I find tension from this? I think I know M2, I know G, I know M2, I know A. Yes, I can. Swappy dance, I think. I have M2G minus M2A. Alec, instead of writing equals tension, do you mind? Can I put tension equals on that side? Because that's kind of what I prefer. Tension is going to be 4.3 times 9.8 minus 4.3 times, what'd they say the acceleration was, Jimmy?
2.5 meters per second.
And are you seeing why I told you it's worth memorizing the units? Because you can just glance at it. Oh, meters per second squared. It's got to be the acceleration. Even if I hadn't said that word. Easy peasy. As someone who hates memorizing stuff, if I tell you to memorize something, it's worth memorizing. What do you get? Give us one in your head, Mr. Oh, maybe. It's going to be 7.8, 7.3. It's going to be 4.3 times, 4.3 times 7.3. Nah, I'm not going to do that one in my head. What do you get? Sorry? 31.39. Anybody else? Yeah? What was it? Sorry?
31.39.
If this was multiple choice, I'd probably, as an answer, 31.4. I might even do 31, because I could go to 2 sig figs. Don't freak out. I don't see my answer yet. It's there. I don't know how much multiple choice is going to be on this test. A little bit, probably about Newton's laws. And I'll give you some really blatant hints about the test on Monday. No surprises on this one. Campbell, what does B want me to find? Let's write an equation for mass 1. Which way is mass 1 accelerating, Gabe? Yep, because which way is mass 2 accelerating? And they're connected by a rope. So with authority and confidence in your voice, instead of saying upwards, which way is mass 1 accelerating? Which force is winning on mass 1 then? Which force is losing on mass 1? Equals M1A. Is that okay, Campbell? Yeah. And you're copying, and that's fine, but you should be able to get that from the free body diagram in front of you without having to squint up at the front, right? Just saying. Ooh. How many M1s do I have, Gabe? In this equation? How many would I prefer? Yeah. This was what we ran into. Oh, we said, first of all, get the M1s to the same side. I think I'm going to plus the M1G over. that okay? Gabe, how many M1s do I have?
2.
How many would I prefer?
1.
Who remembers what was the lovely grade 9 math trick that I could pull out of my back pocket and change this from 2 into 1? GCF. I can factor the M1 out, and I'll have, what will I have in the brackets? A plus G. Gabe, now how many M1s do I have?
1.
How many would I prefer? Woohoo! Oh, get the M1 by itself. What's the bracket doing to the M1, Julia? So, yep. You folks have come a long way, because in September, all this would have terrified you, and I'm seeing bored looks on most of your faces, which honestly, it sounds bad, but it's what I was going for, to the point where you're like, Duick, I got this already. If you're at that point, excellent. So it's going to be, oh no, we want M1, Mr. Duick. M1 is going to be T divided by A plus G. T was 31.39 divided by, what was A, Mr. Duick? 2.5 plus 9.8. Now, built-in error check. Which way was M1 accelerating, Gabe? It's got to be lighter than M2. I can already tell you that it's less than 4.3. If this was a multiple choice question, I might even be able to cross out some wrong answers just by knowing that. It is less than 4.3, I hope. Otherwise, I've really done something wonky. Chase, what'd you get? Oh, you were nodding. I said, it is less than 4.3, and you nodded wisely and intelligently. Those were fake nods. You hadn't done it yet. Oh, let me down. Gabe, what'd you get? Oh. Matt, what'd you get?
3.5.
What, sorry?
2.55.
Is it 2.55? Is that rounded off properly, or is it 2.56? 2.55? These will almost never work out evenly because it's pretty tough for me to back work these and make them work out nice, Nicole. I don't care enough. Ladies and gentlemen, that's the forces unit. We're done. Now, I already assigned the homework last day. Basically, we crossed out 4, 5, and 6. Then it was everything else. Okay. Were there any other questions from the homework that you would like me to go over? Specifically, if you want to get out or look at lesson 7, I can talk about how to do question 7, or I can talk about how to do question 12. But you need to ask. Matt, is there one you wanted me to go over? 12? Sure. Let me emphasize, I'm not going to ask you one this tough on a test. Maybe as a bonus question, I might ask one this tough in Physics 12. If you're signed up for Physics 12, you should know that in Physics 12, I will always put a multiple choice question they've never seen before. I'll always put one nasty. Because in Physics 12, Nicole, I want to teach you, what do I do if I don't know what to do? And leaving it blank and panicking is not acceptable. The phrase you'll hear me use in Physics 12 is, I'll teach you stubborn cleverness. We'll be clever, we're going to be stubborn, we're going to use all the tools in our toolbox and see if we can have that aha moment. I figure if I can teach you that before you go to university, I've done you a huge favor. Number 12. Okay, A says draw a free body diagram showing the forces acting on the box. I'll do that right here. What are the forces acting on the box? Get the obvious one. I think so. Which way is the box accelerating? So which way is my bigger arrow going to be pointing? Okay. There must be a force up, but smaller. Huh? How do you know? Because I see them talking about a bathroom scale. Bathroom scale. So my free body diagram, I think, is going to look like that. I'm guessing you probably got that part okay. And free body diagram for the elevator for part B, I'll do part B right here. I'm trying to keep this all on one screen. So part B, I would have You know what? I'll use capital MG for the elevator and its contents and lowercase m for the smaller mass. It's a trick we do often in physics. We'll use a capital letter for the larger object and a lowercase letter for the smaller object, but that way we can still use our regular letters. And, is the elevator sitting on a surface? So is there a normal force on the elevator? Is the elevator sitting on a surface?
No.
So is there a normal force? No. But it does say it's being slowed down slightly, so it's still accelerating. Ah. Okay. C says, what's the acceleration of the elevator? Is this where you ran into a bit of a roadblock, Matt? Part C? Well, here would be my first thought. Don't write this down yet. In my head, I would say, well, who's winning? Big MG. Who's losing? Friction. That's going to equal big MA. My problem is I don't see friction, a mu or a force anywhere in this question. In fact, what's part D asking me to find? Can't use that equation. What did part A ask me to do? On what? Well, no, what did part A, only part A, ask me to do? A free body diagram of what? The box. Yeah, not the sides of the elevator, just the box. B said the elevator. Why would they have asked me to do a free body diagram for the box? What can you tell me about the acceleration of the box versus the acceleration of the elevator? What? Oh, I thought you said something. Okay. If the box is inside the elevator, what can you tell me about the acceleration of the box? I'm going to find the acceleration of the box to answer part C. Maybe. That's my next strategy. Because my strategy for finding the elevator, don't know friction. Ooh, I wonder if once I figure out the box, will I be able to use that to figure out friction for the elevator in that other equation that I just erased? I just had my aha moment. Let's see. So, on the box, who's winning? Little m, g. Who's losing? Normal force. What's that going to equal? Little m, a. You okay with that?
Yeah.
Get the a by itself. Do I know little m, the mass of the box? What? G, 9.8. I don't know the normal force. Or do I? Because that's what a scale reads. Now, the original question actually on the Physics 12 Provincial gave this in kilograms, and you had to multiply it by 9.8. So I did you that small favor, just to make it stand out a bit more. That should give you the 3.24, I think. You should get a positive answer because I think it still is accelerating down. And then for part D, then I could go, pause for a second. Equation for part D, I think, would be big M G minus friction equals big M A. And I could get friction by itself, swappy dance, and I'll use the A from part C. Is that all right? And you can see if I pause now, Chase, I think that's all Physics 11, but it's seeing how everything fits together. That's what made this an old scholarship question, because kids wanted to try and find the acceleration of the elevator for part C. That's what it asked for, and you can't. But you can find the acceleration of something inside the elevator, which has got to be the same answer. Anybody get that on their own? You did? Nice. Anyone else? A couple of you? That's a tough question. Any other questions from the homework? Did you get A okay? The 3.6? Yeah, I treat that as a 14. Okay? Most people get that one. I figured you'd get that, no problem. What does B want me to find? Emma, my joy. On what? Which mass? The 2. You know what it was a good job for? Okay, this is going to be a little tricky. Let's think about this. So I'm going to do a free body diagram for the 2 kilogram mass. What are the forces acting on it? Get the obvious one. Definitely have mg, definitely have a normal force. Which way is that 2 kilogram mass accelerating? Can you use the word left or right just so? Which way must I have an unbalanced arrow pointing then? Which way is it accelerating? So which way must I have an unbalanced arrow? Okay, this is why Newton's first is so handy. So I know there's a force there. I'm not sure what force that is yet, but I know it's there. Is it tension? Is the rope touching the 2? No. It's not an applied force because there's nothing coming from off the page pulling on it or... What force do you think that is? What's this asking me to find? What force do you think that is? Loud and proud. This is my next thought. I thought, I wonder if that's friction. And then I said, you know what? If this was ice right there, and you yanked on this rope, wouldn't that 12 go right out from underneath and the 2 kilogram mass just drop straight down? You know what's pulling the 2 kilogram mass forward? It's gotta be friction. It's gotta be friction. That's my free body diagram. Who's winning? Who's losing? Trick question. Equals MA. In other words, now for part B, I'll end up with friction equals MA. And that's your answer, the A from part A. That's why you had to do that first. Friction is what times what? Get the mu by itself, divide by the normal force. I don't know the normal force. Oh, but look. Isn't that neat? It's actually, when you see the free body diagram, only then it becomes obvious. But recognizing that what's pulling that forwards is friction, that's the tricky part. And so when I'm not sure, I always imagine sandpaper, Velcro, or ice are my 2 extremes. So something really, really high friction like sandpaper or Velcro, and ice. And then it would make a difference if that was ice. Probably friction is what's doing the job here. Is that all right?